In the summer of year 1950, Enrico Fermi, one of the most brilliant scientists of the last century, was having lunch with his colleagues. On this particular day, the topic of conversation was the disappearance of trash cans from the city of New York and the increased sightings of UFOs. Now, Enrico Fermi was famous for asking weird questions, weird and intuitive questions. Questions like how far a crow will fly before it falls, how many sand particles are there on a beach, or how many piano tuners are there in the city of Chicago. Thinking about the idea of life in the universe, Fermi asked today an even weirder question. He asked a question that will resonate for decades to come. He asked, where is everybody? This question became the basis for what we today call the Fermi Paradox. And today in this video, we will take a deep dive into what is Fermi Paradox, how it relates to the life in the universe, and what are the possible solutions of where is everybody? Where are the aliens? The question about aliens, the question about the life in the universe is something that has fascinated humans for centuries. Everybody at some point in their life has thought about this topic, looked up into the sky and thought, are we alone in this universe? And today we try to answer this question based on the Fermi Paradox. The basis for existence of life in the universe comes from what we call the mediocrity principle. Mediocrity principle basically says that there is nothing special about Earth or the solar system in comparison to all the planets in the universe. There are more planets in the universe than there are probably sand particles on the planet Earth. And since nothing makes one sand particle unique from everything else, nothing makes the solar system or Earth unique in comparison to everything else in the universe. And if that is true, and given that there are over 100 billion stars in the Milky Way alone, in our galaxy alone, and given that half of these stars have a planet similar to Earth, that is neither so hot that life will burn, nor so cold that life will freeze, then there would be at least 50 billion planets in our galaxy alone that can probably sustain life. We call these planets exoplanets or twin Earths, and the discovery of exoplanets revolutionized the whole study of searching for life in the universe. Using the mediocrity principle, each of these planets, each of these exoplanets should have the same probability for the creation of life, for life to start and evolve and turn into sentient beings. And given that the galaxy has existed for over 13 billion years, over the age of the galaxy, many of these planets would have billions of years of a head start over Earth to create life, to evolve life, and to make them into super powerful civilizations. Broadly, we can divide civilizations, intelligent civilizations, into three types, or what we call the Kardashev type civilizations. Kardashev type 1 civilization, or what we call K1 civilization. These are the civilizations that are capable of harnessing the power or energy of their own planet. So for example, us humans are closer to K1 civilization, not completely there yet, 70-80%. Then second is K2 civilization or Kardashev type 2 civilization. These civilizations would be ones which would be capable of harnessing the power of their star. So if we as humans were able to harness the entire energy of sun, we would be K2 civilization, but we are not there yet. K3 civilization are the most advanced, most intelligent civilizations. These would be the civilizations that can harness the energy of entire galaxy. Given the age of our galaxy and given how many of these planets exist, how many of these exoplanets exist, most of these planets and most of these civilizations, if they exist, should be either K2 or K3. Now, everything we know about the terrestrial life, that is us humans or the life on planet Earth, everything we know about terrestrial life tells us that life has a tendency to expand into every corner or every available space. So why should extraterrestrial life be any different? And any K2 or K3 type civilization would be advanced and powerful enough that they can colonize the entire galaxy in a couple of million years. So technically, our galaxy should be swarming, should be filled to the brim with these advanced and intelligent civilizations. And yet, we see no one. So where is everybody? And this is Fermi Paradox. That is, if the universe is filled with life, then why don't we see anyone? Now, throughout the decades, a lot of people have debated, discussed, scoffed, or marveled over the paradox. Many solutions have been presented, and many assumptions made earlier have either been rejected or updated based on the advancements and discoveries in astronomy and astrophysics. Broadly, the solutions of Fermi Paradox can be divided into three categories, and most of the solutions can be summed under these three categories. Category 1 are the solutions based on the idea that ET or extraterrestrial intelligence has visited planet Earth, either today or in the past. And this is the category which is most popular with general public. A large chunk of people still believe that ancient pyramids were constructed by aliens and not humans. And a surprising number of people claim to have had contact with aliens, were kidnapped by aliens, were taken on rides throughout the universe by aliens. So for many people, Fermi Paradox is not a paradox. It is a simple solution that they do exist and they are living with us. Solution 2 are based on the idea that although aliens exist, somehow we have not found the evidence to prove yet. And third is the category of solutions that try to explain why we humans are alone in the universe. Today, we will explore some of the most interesting hypotheses, assumptions, and solutions to the Fermi Paradox. Solution 1. Rare Earth hypothesis. The rare Earth hypothesis is based on the idea that life is unique, that life requires an extremely high number of variables to happen just in the right order for it to exist. From the placement of Earth in the galaxy, neither too close to the chaotic center nor too far in the frozen outskirts. The distance of Earth from the sun is not so close that life will burn and not so far that life will freeze. It is in fact what we call the Goldilocks zone. The distance is sufficient for the water to exist in the liquid form. Even some unlucky events like the asteroid that killed all the dinosaurs from planet could have played a crucial role in the emergence of life. It allowed the life on planet Earth to restart, and it gave a new opportunity for different forms of life to start. The right chemical composition, the magnetic field of Earth, the movement of tectonic plates, all of these small variables, they play a crucial role in the emergence of life. So, although there are a lot of planets in the universe, but the possibility of all these things happening to all those planets in the right sequence, in the right order for the life to emerge is extremely low. Solution 2. The self-destruction hypothesis. The self-destruction hypothesis suggests that the advanced civilizations inevitably self-destruct before they can start interstellar communication or travel. As civilizations develop advanced technologies, they develop the ability to self-destruct. This could be through nuclear powers, biotechnology, or AI, or even something that we humans have not yet thought about. Advances in biotechnology could inevitably lead to extremely dangerous pandemics, or advances in artificial intelligence inevitably lead to a system that destroys their creators. So it is logical to think that a civilization that becomes more and more advanced would inevitably face these challenges where their own creations would destroy them. Now, since this hypothesis assumes that advanced civilizations destroy themselves before they can start interstellar communication or travel, it makes sense that we don't see anyone in the universe. Solution 3. The Great Filters. The idea of great filters is based on the fact that the emergence of life passes through various stages, and each of this stage could act as a filter to block life from evolving from one stage to the next stage. Imagine that there are 100 billion planets in the galaxy. Not all of these planets would have the possibility of life, would have the appropriate conditions for life to evolve. So the first filter will be the habitability of the planets. Now, out of all these small number of planets left that can sustain life, not all these planets would have the process of abiogenesis. That is, the ability for inorganic matter, the non-living matter, to transition into simple replicating molecules, or what we call the life molecules. And out of all those planets which would have intelligent life, not all that intelligent life will transition into advanced civilizations. So each of these stages would work as a filter. So the great filter hypothesis basically argues that although there are so many different planets, their life is possible, but since there are so many different filters and one of these filters could destroy life, it makes sense that there are only very select few or even one single planet that can carry life today. Solution 4. The Dark Forest Theory. This theory interestingly comes from a science fiction book by the same name, The Dark Forest. And it suggests that the universe is like a dark forest, and the civilizations are like the hunters hiding in this forest. And each of these hunters are trying to avoid each other, to avoid destruction. And since these civilizations are like hunters hiding in the dark forest, are trying to avoid each other, it would make sense that we don't see anybody trying to contact us. This creates a universe where the civilizations try to avoid broadcasting their existence and try to remain hidden. Solution 5. The Incubation Theory. This hypothesis suggests that other civilizations, just like Earth, are in a dormant state right now. That is, they are not advanced enough that they can travel in the universe. They are not advanced enough that they can colonize other planets. So even if they exist, they are more focused about their internal matters, solving and prioritizing their own internal struggles rather than trying to colonize the entire galaxy. It would make sense if the life on other planets would have originated almost at the same time as it has originated on Earth. So that would explain why we do not see anybody in the universe. Solution 6. The Early Bird Theory. Someone always has to be the first one. And on this cosmic scale, we just happen to be the first planet where life emerged and got to the stage of intelligence. So there might be other planets going through the same cycles who are not yet advanced enough. So the early birth theory basically suggests that although the possibility of life exists in the entire universe, we just happen to be the first one that got created. This solution is based on the fact that the universe is extremely large, mostly filled with space. The distances between the closest habitable planet from Earth is taken in light years. Given the large distances between these planets, the interstellar travel might not be sustainable. The advanced civilizations could have at some point realized that it is not exactly worth going from planet A to planet B to colonize it. The amount of resources involved in interstellar travel might be too high. The analogy could be something like this, that imagine a country, one of the most powerful countries on planet, wanted to capture or colonize one of the smallest countries on Earth. But in order to colonize this country, if they had to spend 90% of their resources, it would not be economical for them. So interstellar travel or communication could be uneconomical. The zoo hypothesis is based on the idea that extraterrestrial intelligent civilizations are aware about us. They are aware about the existence of humans, but they deliberately avoid contact and they observe us from a distance, just like humans observe animals in the zoo. This could be due to their policy of non-interference. That is, they follow a policy of not interfering with the evolution of other life forms in the universe. They might believe that interfering with our development or interacting with humans could have negative impacts on how we develop. Advanced civilizations having an intelligence level higher than humans could very well hide their presence from us, and irrespective of how hard we try to find them, we would not be able to see them. The simulation hypothesis is an extremely provocative idea that proposes that our reality, including the universe we live in, is actually a sophisticated simulation being run by an advanced civilization. This hypothesis provides an interesting angle to the Fermi Paradox, proposing that the reason we have not yet discovered any extraterrestrial intelligence is because us, including the solar system and the entire universe, is part of a simulation and not technically real. This is an interesting hypothesis because if we consider a civilization which is extremely advanced, then they would have the capability to run advanced simulations advanced enough that they can make the entities inside these simulations think that they are real. There is a very famous philosophical foundation related to this simulation hypothesis. Philosopher Nick Bostrom proposed that at least one of the following statements is true. A. Almost no civilization reaches the capability to run an advanced simulation. B. Almost no civilization is interested in running a simulation of their own history. Or C. We are most certainly living inside a simulation. And given the vast number of possibilities that an advanced simulation can run different kinds of simulations, the probability that we are in the base reality, that we are the reality in which we will do these kind of simulations in future, is extremely low. And if the technology is advanced enough, and the simulation is advanced and sophisticated enough, the entities being simulated would not know that they are inside a simulation. All sensory experiences, all your memories, the history, the things that you remember, your loved ones, your parents, your girlfriends, and your boyfriend would be part of this simulation. Now, the simulation theory in itself is so interesting and sophisticated that I can make a separate video of this theory itself, because there are so many different angles, there are so many different perspectives I can have, so many things there are to talk about. So maybe at some point, maybe I will talk about this simulation, as long as the people who are simulating me decide to do that. Now, before we close off this video, there is one thing that we must talk about. Recently, Harvard researchers published an interesting study. They claimed that aliens, in fact, are living among us. They tried to study different possibilities in which how aliens could be living among us. They tried to study the possibility of aliens hiding underground, aliens being disguised, concealed among us, or separate evolution. An intelligent species might have evolved on planet Earth along with humans and would have remained undetected because of their higher level of intelligence. So according to this theory, your neighbor or that weird friend of yours who always comes late, who never pays for his food, might in fact be an alien. I definitely have friends who are weirder enough to be aliens. We have discussed about the Fermi Paradox and its possible solutions. But one important thing to look, while the answer to Fermi's question, where is everybody, may not be simple. While the possibilities of whether the aliens might be living with us, might be observing us from afar like a zoo, we may be living in a simulation, or we may be the only one in this universe. While all these possibilities exist, one thing is for sure. Like Newton once said, that I am like a child playing on the beach, happy on finding a smoother pebble, a smoother stone, while the entire ocean lies just beyond my sight, filled with all the unknown truths. I may have butchered the quote, but the gist is basically the same. Irrespective of what the possibility of life in the universe is, irrespective of what the answer to Fermi's question is, irrespective of where the aliens might be or may not be, the reality is we understand extremely little about the universe. There is a huge amount of knowledge gap in between what we know and what we should know in order to understand where everybody is. Maybe we will be the first civilization that travels across the boundaries of the space and colonize the galaxy. Maybe we will eventually suffer one of these great filters and be destroyed. But one thing is absolutely clear: the complexity of life is extremely beautiful, and each passing day that we do not find the evidence for extraterrestrial intelligence adds to the fact that we are the only living beings in this entire universe. And while this idea may be daunting, while this idea may be slightly depressing, it makes the fact that we are the sole living beings, sole living owners of this entire universe an amazing marvel. Thank you very much for watching this entire video. I have tried to put together all my thoughts on this topic, and this topic is of course a little bit complicated because it has so many different angles with which I can come at it. So many different theories, so many different point of views, and each of these can be made into an entire video in themselves. So many different things can be added to each of these theories and hypotheses. At some point maybe I will take one of these topics and explore them in a little bit more details in one of the videos. But for now, I felt giving an overview of all these different topics was much more reasonable. I didn't want to make this too big. If it has been big, thank you very much for watching this till the end, and hope to see you in the next video. Whatever the answer to this question is, I'm just happy to be a human. I hope you are too. If not, it took me a long time to make this video. Just like it, subscribe it, kindly please. I don't really care anymore. Bye.